Okay. So, in statistics, when we talk about the four moments, generally mu1, mu2, mu3, and mu4 are the four moments about the mean. Okay. The first moment, about the mean. So, about the mean, the first moment is zero. Second moment turns out to be variance. Third and fourth moment, why we discussing? Usually, students will have a doubt. The reason behind why we discuss second and third moments is that we ought to know about the skewness of a curve. Now, what exactly is skewness? If you ask me, then just see here. Suppose if I have a data and I have plotted its curve. Okay, I have a curve of this type. I also have a curve of this type. Okay, maybe this is not so apt. I have a curve like this, or I can as well have a curve of this type. What do you understand by looking at these curves is, what you should understand is, in the first one, the curve is this in the first one, the curve is completely towards the left. In the second one, the curve is completely towards the right. But if you observe the third curve, is exactly centered at the centered in between. Okay, neither it is completely towards its left or nor it is completely towards its right. Suppose if I talk about it in terms of the measures of central tendency, what are they? As mentioned earlier, they are mean, median, and mode. Okay. Now, if I have mode, median, and mean. Okay. Now, I'll be telling that for one case to be positively skewed, the other one to be negatively skewed. What is positively skewed is mean is maximum and mode is minimum. In such a case, mean is maximum. I think the way I've notated has to be changed a little bit. What that is mean is maximum, mode is minimum. So the tip of the curve should have mean only. Okay. Now mode is minimum. You can clearly see here. In such a case, I'll call this to be positively skewed. Or in other words, median lies between mode and mean. Okay. Positively skewed. What is negatively skewed if you ask me? What is negatively skewed if you ask me? Mode will be maximum. Mode will be maximum. Mode. Mode will be maximum. And median lies between, mean will be minimum. Mean will be minimum. And median lies between mode and mean. Okay. Of course, in both the cases, median lies between mode and mean only. But in the second case, mode is maximum, mean is minimum. In the first case, mode is minimum and mean is maximum. In such a case, you'll call it to be positively skewed, negatively skewed and all. And skewed data is always not ideal. Okay. What is an ideal data is that data where all mean, median, and mode coincide. That would be called an ideal data or no skewed data. Skewed data is always not ideal. Okay. Yeah. So, what exactly is skewness if you ask me? Skewness, clearly looking at the curves, I can put it like this. Lack of symmetry. There's no symmetry. Lack of symmetry is skewness. Okay, in the shape of the distribution, in the shape of distribution of the data that's been given, shape of the distribution. Okay, that means what? Mean, median, and mode fall at different points. Quartiles are not equidistant from the mean, from the median. The curve is stretched to more towards the left or right. What is that? Mean, median, mode. Fall at different points, fall at different points. Quartiles are not equidistant. Quartiles, usually quartile should be equidistant. The second quartile is the median. Okay. Quartiles are not equidistant. Curve is stretched. Curve is stretched more to one side than the other. More to one side than the other side. Okay. In such a case, you will say that the curve is skewed. Okay. Positively skewed and negatively skewed. There are two ways, two mathematically most famous ways of calculating skewness. One is the Karl-Pearson coefficient of skewness. Karl-Pearson coefficient of skewness. Okay. The other one is Bowley's coefficient of skewness. Bowley's coefficient of skewness. Okay. There is a range for Karl-Pearson and there's a range for Bowley's as well. Okay. The limits for Karl-Pearson coefficient are -3 less than or equal to. Skewness usually denoted by SK less than or equal to 3. Bowley's is -1 less than or equal to, SK less than or equal to 3. What does SK stands for is skewness. Okay. Yeah. In the next video, we will see about the formulae for Karl-Pearson and Bowley's coefficient. Now, coming to Kurtosis, guys. Kurtosis again. KUR. Kurtosis is, see, I'll have a curve like this. I'll have one more curve like this. And I'll have one more curve like this. Okay. I can clearly see this one is more flat. So Plato-Kurtic. Okay. Yeah. This one, the curve B, let me call this to be C and this to be A. Curve B is called to be mesokurtic. Mesokurtic. Neither too flat nor too peaked. The last one is A is leptokurtic. Leptokurtic. Too peaked. Too peaked one is leptokurtic. Normal one is neither peaked nor flat is mesokurtic. The flat one is Plato-Kurtic. And again for mesokurtic is again for normal distribution, guys, where all mean median coincide and all that. The one which is flat, okay, the type C one, mesokurtic one, and the Plato-Kurtic one. For the type A, which is neither flat nor peaked, type A or type B, which is neither flat nor peaked, would be called normal curve. And ideal beta value should be 3 and gamma 2. Beta 2 should be 3, gamma 2 should be 0. Okay. Yeah. Why? Because gamma 2 formula is beta 2 minus 3. Okay. So gamma 2 should be 0. Yeah. Now, which is very flat would be called Plato-Kurtic, which is too peaked would be called leptokurtic. Okay. Now for leptokurtic, the curve A, beta 2 should be greater than 0 and gamma 2 also should be greater than 0. No, beta 2 should be greater than 3. I'm sorry. 3 is the measure. Why 3? Again, I will talk about it. Now for the Plato-Kurtic, beta 2 should be less than 3 and gamma 2 should be less than 0. Okay. Ideal ones are beta 2 is 3 and gamma 2 is 0 for normal curve. Normal curve or the Gaussian curve, which is neither flat nor peaked. Okay. I'll talk about remaining things in the next video.